So first thing I'm going to do with f of x here is try and simplify the pieces of the function. Looks like it could pull out, well, actually, it looks like we've got a difference of squares in there. We've got x squared minus 4x times x squared plus 4x. Okay. There's that way that comes to mind, and I'm just kind of poking around with this one. I don't know, maybe I should just factor an x squared out of both. That would leave an x squared minus 16. And since x squared is a factor of everything, I can let it escape as an x. And then I'd have x minus 4 times x plus 4. That actually feels like the best, most concise look at the function right here. So maybe with this I'll start thinking about domain and range now and how to attack this analytically. Obviously some boundary numbers are going to be positive and negative 4. Positive 4 is going to get me to 0 here. Negative 4 is going to get me to 0 there. So on a number line, I'm going to mark those and kind of do some analysis. Negative 4, positive 4. And the question is the domain happening below negative 4, in between the two, or above positive 4? Where is this function having outputs? Which parts of these x values is producing output? So let's try some test values here. How about 0 for that region, 5, and then we'll try negative 5. Okay. Now if I put negative 5 in, you could see that I will have, in this first factor, negative 9. In the second factor, I'll get negative 1. And those two will multiply to be 9. So this one's okay. In fact, we're okay with negative 4 and everything below. So that negative 5 being a test point kind of told me, oh, the negatives will cancel out inside and I'll have a square root of a positive thing. That's fine. Let's try 0. Let's test 0. Okay, so if I put, this is getting a little messy here. Let me write this out. If I put 0 in, I get negative 4 times 4, and I'm going to get negative 16, which is undefined. Okay? So this is not part of the domain in the middle here. That DQs that whole region of numbers. Let's try 5. Okay? By the way, I already know that 4 is going to work because it produces 0, and the square root of 0 is 0. So I know 4 works. And I'm suspicious that 5 works too, but let's see with the test point. So, square root of would be 5 minus 4, which would be 1, times 5 plus 4, which would be 9. So you get a positive times a positive, and I get root 10, which is a totally real number. So we end up having all the values above and including 4. So our domain can be written as negative infinity up to and including 4 union 4 to infinity. And I actually meant negative 4. Thanks. Actually, shame on me. We just realized that the x we factored out, where did that go? Oh yeah. Produced a 0. In fact, if you were to just leave it inside here, when x is 0, you get 0. So our domain should include, I missed this the first time, negative infinity up to negative 4, inclusive, union, gosh, how would I write this? I think I can use a set bracket 0 for including a single value, union, running out of room here, inclusive 4 up to infinity. That would be the domain. Range, after inspecting the graph, we could see that everything from 0, including 0, up to positive infinity appears in the range.